Okay, this is familiar territory for us, so just a quick review. You're saying you're trying to find out what you can raise 4 to the power of to get a 16. 4 to what power equals 16? The answer is 2. And through a lot of these things, again, log of 1, anytime you take the log of 1, regardless of what's down here, the answer's got to be 0 because 5 to the 0 power equals 1. So whatever that base is, if you're taking the log of 1, the answer's going to be 0. And so I tell my students, anytime you do a problem like this, it's really a review of exponents and getting you practice doing the stuff that you're doing here. So if these two numbers match here, log base 10 of 10, again, 10 to what power is going to remain 10? Well, it's got to be a 1 because 10 to the first power equals 10. Now you flip it over, this is still a 10, but now, again, this is the review of exponents. How do you turn a 10 into a 1 over 10? Well, it's got to be a negative exponent. So the negative is what flips it over. The 1 keeps it at 10. We saw this stayed at 10 because you raised it to the first power. We want it to remain at 10. We just want it flipped upside down, so that's why the negative comes into play. Then you look at the 1/3. Okay, we're taking 1/3 and we're turning it into a whole number. So it's the opposite of this, but we're doing a lot more with that, obviously. I know that the answer's got to be negative because I'm taking a fractional number, turning it into a whole number, but I also know it's going to have to be, bigger than 1 because this is not just a 3, it's a 243. And the more you do this stuff, the more you start to get familiar with these numbers. But 3 to the 4th power I know is 81, and an 8 times 3 and a 1 times 3 is a 24 and a 3, so whether you followed that or not, 3 to the 5th power is 243, so it's a negative 5 because the fraction turned into a whole number. You look at other things, I'm not going to do them all. You're turning a 9 into a 3, it's got to be smaller. It's not a divided by, but it's a power. What power can you raise 9 to turn it into a 3? Well, the square root of 9 is 3, and the square root of a power is a 1/2 power. So we're looking at negative exponents, fractional exponents. It's just a matter of reminding us how to do it. Both of these, turning a whole number into a fraction, you're turning a fraction into a whole number. Both of these numbers are going to be negative, but I'd like you to try and same thing. Here, well, we'll look at this one. 16 into a 1/4. Okay, let's first of all understand that it's a whole number into a fraction, so it has to be negative. That's why it's negative. So ignore the 1 for now. We're thinking of too many things at once. It's hard to do anything. I know it's negative, so forget about the fact this is a fraction. I'm turning 16 into a 4. How do you turn 16 into 4? Well, you take the square root of it. Oh, that's right. The square root's the same thing as the 1/2 power. So this is a negative fractional exponent. If you can kind of follow that, you're looking good. This one's one of the tougher ones. 27 to what power is equal to 81? For a moment, you may just want to come over here. 27 to the x power equals 81. Well, 3 is involved. 3 has got to be involved. And so if you can melt this thing down to be a 3 and then raise it to a power, it'll be turned into an 81. So how do you melt this thing down? Well, the 3rd root of 27 is 3. So I know that x is going to have a denominator of 3 because that's what created that 3rd root. But after you get that to be a 3, then you've got 3 to what power is equal to 81. Well, the 3rd power got us to 27. The 4th power turns it into an 81. So that's a 4 over 3. You could either kind of logic your way through it that way, or you can do the common base thing, where this one here is really 3 cubed to the x power, and this right here would be 3 to the 4th. So you get your 3, and I don't have space, I should have been more prepared for this. You get your 3 to the 3x power equals 3 to the 4. Now you got your common base. Now you can just ignore them for the moment and say, well, 3x then must equal 4 if you divide by 3. You get the same answer that you got that way. And the last one here, you're going to get to know this more and more. When this base matches that base, if this is an exponent, the answer is that. Same thing up here. This base matched that base. It had a power of 1, so that was sort of hidden there, but it stands to reason, and I'll show you why. If we say it's equal to x again, then we have our 2 to the x power equals 2 to the 5th. So the more you set that up, the more that's going to become familiar, and the more often you're going to say, oh wait, when this matches this, then that's the answer. The answer is 5.